Hello, in this one I'm going to talk to you about the concept of a sum that diverges because of oscillation. So we'll explore in some detail. So here's an example, okay? Lower index n equals 1 and then goes up to positive infinity. The term is negative 1 and it's raised to the n. And notice that it's negative 1 within parentheses. Let's actually write this out a few times for different values of n. So here, when n has the value 1, that means the exponent is 1, you get negative 1 plus negative 1, notice that's the base, it doesn't change, so it's always the same negative 1, raised to n equals 2 now, plus negative 1 raised to n equals 3, plus negative 1 raised to n equals 4 in that position, and then plus dot 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 to indicate that, well, I'm showing you only, I believe, 4 of these. In reality, this will just continue forever and ever and ever and ever, okay? So what I can do now on the right side is continue. I'm going to use negative 1 in this position because back here, when I do negative 1 to the first, that is negative 1. So I'm going to call that a sub 1, the first term essentially, subscripted with the 1. Next, negative 1 to the second, that's going to be positive 1. The reason is, of course, it's negative 1, which is positive 1. So that's a sub 2. Next, I'm going to do negative 1 to the third. It's going to be a sub 3, that's negative 1 above my head there. Okay, and then I have negative 1 raised to the fourth, which of course will be positive 1. That's a sub 4. So the dot 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 means this would just continue that way. I'm going to zoom back out a tiny amount and look at this graph here. Okay, let me zoom in on this graph. What is this graph telling us? Everything tells a story, right? So here on the vertical, what you have is a sub n. That's the value of the term, essentially. And on the horizontal, what you have is n itself, which is the subscript value. So look at n equals 1. Remember that our first term was negative 1. So that's below me there. A sub 1 equals negative 1. Okay, and when n had the value 2, the output was a sub 2 equals 1. That's our second term. When n has the value 3, the output is negative 1. So a sub 3 is negative 1. When n has the value 4, and a sub 4 equals 1. So when n has the value 5, the output is a sub 5 equals negative 1. When n has the value 6, the output is a sub 6 equals 1. And the dot 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 means, or rather mean, when you take them together, that this pattern continues of going up and down, up and down, up and down. So what is that telling us? It's telling us that clearly, just by looking at this, that the terms are oscillating from negative 1 to positive 1. Does this have any impact on the sum? It clearly will. This is what I mean. Let me zoom over to the next graph, okay? Look at this next graph. So here I have s sub 1. That's the first partial sum, if you like, which also happens to be equal to just the first term. That's negative 1, okay? But look at s sub 2. So how do you form s sub 2? That's the sum of the first two terms. And notice that its value is 0. So let me zoom out so we can see things better and make sure that we can, put the pieces together the right way. So go back over here to the left graph. If you do negative 1, which is a sub 1, and you add to it a sub 2, which is positive 1, it's negative 1 plus 1, which is 0. So that shows up as this dot. S sub 2 equals 0 for that reason. Now look at S sub 3. That's the sum of the first three terms. So go back over here and look at the graph. It's negative 1 plus the positive 1, which is 0. 0 plus negative 1 is negative 1. So that shows up over here as S sub 3, the third partial sum. These are called partial sums, remember, because S sub 1 is the sum up to n equals 1. This is the sum up to n equals 2. This is the sum up to n equals 3, and so on. It's not the entire sum, it's just up to a particular value of n. Look at S sub 4. That means add up the first four terms. Go back to the graph on the left. Negative 1 and positive 1 is 0. 0 plus negative 1 is negative 1. Negative 1 plus this 0, that 1 rather, would give you a sum of 0. So when you add up a sub 1, a sub 2, a sub 3, and a sub 4, that's going to give you a value over here of 0 for that reason. S sub 5, that means basically add up the first 5 terms. That's going to be negative 1. S sub 6, that means add up the first 6 terms. Guess what? That's going to be 0. S sub 6, well, look, you have 3 below, that's negative 3, 3 above, that's positive 3, and negative 3 is 0, right? It stops at a sub 6. So that shows up here in S sub 6, meaning the sum of the first 6 terms is 0. And when I look at this clearly, I can tell by inspecting this graph that the sum goes S sub 1, S sub 2, 0. S sub 3, negative 1. S sub 4, 0. S sub 5, negative 1. S sub 6, 0. It's oscillating. It's not settling down to a particular value at all. And again, the dots here mean that this kind of oscillation and this value of the sum would just go up and down like this forever, essentially. It would never stop. So what you can say here, to zoom out, is the following, to summarize everything. The question was, does this sum converge? This is sum right here. So the sum doesn't converge because it oscillates from -1 to 0, okay? That's the answer, if you like. So this is an example of a lack of convergence, or if you like, divergence, not because the sum is infinitely positive or infinitely negative, but because it just jumps between two different values forever and ever. And that's it. Thanks so much. Leave a like and subscribe. I hope it's been insightful. I will see you in another video.